Hi, this is Jason, the Falling Entropy. In this video, I'm going to go over energy for an elastic body that's undergoing deformation. This could be either a freely moving object in the air, undergoing inertial forces. It could stretch. But here I have an example of a beam, a cantilever beam on a wall. And in that case, it's a fixed body, but it'll still have the same elastic deformations. The other video I did earlier today was on rigid body motion, which does not include deformation effects. So the energy equation is still the same. It's also known as work. And there is it's force times distance, or F times X. And again, for an elastic body, we're talking about deformation. So here I have a beam that has an axial force on it, just pushing the beam in against this wall. And this symbol here is used for a boundary on a wall. And the energy we're talking about in this case can be called strain energy or a type of potential energy. So basically, I'll push in on the beam and it'll displace, right? But one thing that's important in the equation is the existence of a 1/2. And what that does is that if you look at this equation here, it's energy equals force times X. And then we have another X, because this is actually the response. So force is like a reaction force. It's a stiffness for force where the body's resisting the force. So it replies back with a stiffness, right? So this F is not really, it's equal to the reaction of the beam, of the stiffness, which is also, that force in the equation of motion is stiffness times displacement, X. But this X is also displacement. So it comes out where you have an F times X, but we replace F with 1/2 kx. So you have X's are now squared. And the reason for the 1/2 again is that the strain at the wall here, it'll have zero deflection. And on the max tip here, it will have max deflection. So basically you put 0 in for the wall and max in for the tip. And where you kind of you average the force, because it'll vary linearly through here. This reaction force and the strain will vary linearly. So we just give those a simple average. So if you average that reaction here with this reaction here, you divide it by 2. It's 2 locations. That's the average. So that's where a 1/2 ends up. But there you have it. That's for a simple axial rod type of motion. It gets more complicated with the strain energy. Eventually you need finite element programs to calculate stuff. But this is a good simple explanation about elastic strain energy. So, alright, if you have any questions, leave some comments. Thanks.